Hello everyone, myself Geeta. Today in this video we are going to see about some standard results on integration. The first one which we are going to look into would be d by dx of integral f of x dx is going to be equal to f of x. Differentiation and integration are inverse operations. That is what this particular result means actually. So let's prove this. So when I'm proving it, I'm going to consider this integral f of x dx. When I integrate something, a gradient when I'm integrating, I would be getting a function. Let that function be phi of x. Obviously, it's an indefinite integral. I would be getting plus c. So then further, when I differentiate, whatever the result I got, the function phi of x plus c, I would be getting here because just see here, this is going to be my gradient. And when I integrated a gradient, I'm getting a function. So when I differentiate a function, obviously I would be getting a gradient. So you would be getting f of x. So when I differentiated this one and constant when I differentiate, obviously it's a number. When I differentiate, it becomes 0. So I got a result f of x. So it clearly states that when you differentiate and then integrate a function, you would be getting the function as it is f of x. So if you want, let's see with an example. Suppose when I integrate x to the power 4 dx, I would be getting x to the power 5 by 5 plus c. It's an indefinite integral, so obviously I would be getting c. Now when I differentiate d by dx of x power 5 by 5 plus c, you would be getting 1 by 5 into 5x to the power 4 plus c. When I differentiate, it becomes 0. So 5 gets cancelled. I get x to the power 4. So that is what is all about. So that's what the definition is. And see here, it's very clearly it states that differentiation and integration are inverse operations. That means when I get both of them together like this, obviously these two would be getting cancelled and f of x would be left out. That is what it means. Okay, that's your first one. So first one of my result was differentiation and integration are inverse operations. So now the second result. The second result, when I have a constant getting multiplied with my gradient, my constant would come out and the remaining things would be getting integrated. So dx, where k is a constant, obviously. K is a constant. Here also the proof I'm going to rely on differentiation. Then only I would be able to prove it. So now here, let's see. So now here again, let's integral f of x dx. Whenever I do, the function which I'm going to get is phi of x. Okay, let's consider plus c or without both, because when I differentiate, plus c would go away. That's the reason I'm not mentioning. When I have d by dx of phi of x, I would be getting f of x. I think till here it's clear. Now when I differentiate d by dx of k times of phi of x, I would be getting a result k, I would take it out, and then d by dx of phi of x. That means I'm going to differentiate only the function but not the constant. K, I'm taking it out. Then in that case, I would be getting k of f of x. I got it? Now you let us mark it as 1 and then I'm gonna keep it as it is. Now I'm going for integration k of f of x dx. As usual, I'm gonna take k out, then you have integral f of x dx. What is your integral f of x dx? In the very beginning, it is nothing but phi of x. So you would be having k times of phi of x. Okay, that is by the definition what I defined in the beginning, the assumption what I made. So based on that. So it's very clear from this, whenever I have a constant along with the gradient, the constant I would be taking it out and then integrating the function, the gradient. This is how we would be doing it. So I think you understood. Under this, we have a corollary or in this, if my f of x is going to be equal to 1. In that case, integral k times k dx, when I have k would be coming out, k is a constant, and then I have only dx. When you integrate dx, what does that mean? It means when nothing is there, 1 is there, means it is x raised to the power 0 dx. And when you integrate x raised to 0, power 0, it is x to the power n. Integration formula is going to be x raised to the power n plus 1 by n plus 1 plus c. And then here I have x raised to the power 0 plus 1 divided by 0 plus 1. And then plus c is there. So which means that k times of x by 1 plus c. This is how we would be doing. Okay, if you want, you can put it here. I just wanted to put it in a final stage. That's it. So this is how it would be. Whenever you don't have any 1, if you have just integrate dx, that means your answer is going to be x. Because if nothing is there here, 1 is there, then only any number multiplied by 1, well, then only I would be getting dx. That means 1 is nothing but x to the power 0. So when I apply the integration formula, it becomes x raised to 0 plus 1 divided by 0 plus 1 plus it. So based on that only, this has happened. Hope you understood. Now let's move on with the third one, which says integral f of x plus or minus g of x dx. Whenever you are having like this, in that case, you would be integrating separately for f of x dx, and then you would be plus or minus g of x dx. When it is two terms together, it has been given like this. In that case, we would split them and then do the integration. That is what it means. And now let's do the proof of this one. Now let me consider, let integral f of x dx is going to be equal to phi of x. And then integral g of x dx is going to be equal to, let me take theta of x, anything. So this is how I have done. Now when I differentiate my phi of x, I would be getting f of x. Because we know when I integrate a gradient, I get a function. When I differentiate a function, I get my gradient back. And the same way it goes for this one also. When I differentiate theta of x, I would be getting my g of x. So it holds good for like you would have understood how I'm writing this one. Okay, now we have d by dx of phi of x plus or minus d by dx of theta of x. So which is nothing but my f of x plus plus or minus g of x. So this implies d by dx, when I take it as a common and then write it as phi of x plus or minus theta of x, is gonna be equal to f of x plus or minus g of x. And then now, when this d by dx goes to the other side, it becomes integration symbol. F of x plus or minus g of x dx is going to be equal to phi of x plus or minus theta of x. So now, what is this equal to? Integral f of x plus or minus g of x dx is equal to, what is phi of x? It's nothing but integral f of x dx plus or minus, what is theta of x? It's nothing but integral g of x dx. We have proved it. So all this is relying on one simple concept, that is, when I integrate a gradient, I get a function. And when I differentiate that function, I would be getting the gradient. Same thing. And when you have, like when I'm adding this and this with plus or minus, I would be getting f of x plus g of x. And here I'm taking d by dx common, and then I'm writing it as phi of x plus or minus theta of x. And then when this d by dx goes to the other side of the equation, then it becomes an integral sign, because we have done differentiation and integration are inverse operations in the beginning. So based on this, it would work. Now in that case, what would happen? This differentiation, when it goes to the other side, it becomes an integration. Now you have f of x plus or minus g of x dx. Now, in this case, what is my phi of x? It's integral f of x dx. That is what in the beginning we have defined. And then what is my theta of x? In the beginning we defined it as integral g of x dx. So that's it. These are the three important and rules which we have under integration, the standard results which we have. So if we follow this, the problems would be easier. So all the three rules are a basic rules which we have. These basic rules results, actually, if I have to put it in a correct way, these are the standard results which we have. If we follow, the problems would be easier. In fact, we are going to do problems based on this. So in the next video. Thank you.